Hey guys, it's Coach Sharf. Welcome back to my video notes and examples. Obviously, again, doing this one from home because I got to stay at home for a couple weeks. I've been at home for about a week or so. Um, Trying to knock out two videos tonight on what we're doing this week. Again, this first one is inverse functions, and the second one is going to be compositions of functions. Well, we'll go ahead and get started here with the inverse functions. Okay. So I know the screen's a little shaky because I'm on this card tomorrow. I'm gonna try to keep my weight off as much as I can. It won't affect the active board. Just maybe you seeing the screen wiggle with me in the corner. That's fine. All right. So we got inverse functions. Okay. So the whole idea behind inverse functions is if we're given a function f of x. So again, f of x equals 2x plus 4 for an example. I need to find the opposite function that flips my inputs and my outputs. That flips my inputs and my outputs. What does that mean, Coach Sharf? So again, it means that if in your original function you plug in 3 for x, okay, so you got f of 3. Wherever you see x in the function, you put 3. So you got 2, it was 2x plus 4. So you got 2 times 3 plus 4. 2 times 3 is 6, plus 4 is 10. So I plug in 3, I get 10 as my answer. Okay. So I need to find the opposite function that flips that. So I need to find a function where I plug in 10 and then I get 3 as my answer. Okay. And the key with that, which y'all see on the next slide, is it's going to have to do it for every pair of numbers. Like it can't just happen to match up for one pair of numbers. It's got to do it for every pair of numbers. And we'll see that on the next slide. Inverses are shown with the f -1 of x notation. Again, this -1 looks like an exponent, and you kind of write it like an exponent, but it doesn't mean anything mathematically. That's just how we designate inverse functions. All right, so I cleaned this up a tiny bit from how I did in the notes in class. So I was kind of all over the place when I did that, trying to make this bigger. There we go. Let's move me out of the way as well. All right, so in terms of flipping our inputs and our outputs, okay? If I'm saying my original function is f of x equals x plus 3, and I want to ask, is this my inverse function? So I guess I should put that. Is this the inverse function? Okay. F of, not f of -1, f -1 of x, excuse me, equals x squared, x divided by 2, I can't talk, plus 1. So again, we said the opposite function. So again, we'll talk about a little more depth in a minute. So just look at the functions themselves. You know, I know things in math can surprise us sometimes, but if you're just looking at x plus 3 and x divided by 2 plus 1, you're saying, Coach Sharf, that I mean, how could those be opposite of each other? So again, we'll get that in a little more in a minute, but let's start with an example, okay? So I'm going to plug in 5 for x right here, okay? So I'm going to start really easy. I'm going to plug in 5, okay? It's going to give me 5 plus 3 equals 8. So I'll plug in 5 and get 8 as my answer. All right. So now I want to test if I plug in 8 for x, well, I get 5 as my answer. So I'm going to plug it in here. I've got 8 divided by 2 plus 1. 8 divided by 2 is 4. 4 plus 1 is 5. So this one checks off. Okay, it worked for that one. I plugged in 5 here. Got 8. Okay, and then I plugged in 8 over there and got 5. But again, the key is it has to work for every set of numbers. Okay. And again, I was trying to look at one point. I wasn't able to. I was trying to find a possible example of two functions where maybe multiple pairs of numbers worked, but not every pair of numbers worked. And I'm sure if I dug hard enough, I might be able to find one, but for the most part, if you find two pairs of numbers that work, every pair of numbers should work. So I'm trying 12, okay? If I plug in 12, get whatever number I get, plug that number back in here and get 12 again, then they're inverses, all right? So let's plug in 12. We'll plug in 12. 12 plus 3 is, of course, 15. So I plug in 12, I get 15. So that means over here, I should be able to plug in 15 and get 12. Well, let's try that. Got 15 divided by 2 plus 1. 15 divided by 2 is 7.5 plus 1 is 8.5. I know I'm getting small in the corner there. So that one did not work. Okay. So these are not inverses. Okay. These are not inverses of each other. Again, this is, let me reemphasize that too, although I don't really know if you're going to need, see it at any point. If I'm saying this is my original function and this is my inverse, okay, the same would still be true if x divided by 2 plus 1 was my original function. I would say this is my inverse, okay? They're going to be inverses of each other. So, again, here, let's pretend that I start with this. If I plugged in 8, 8 divided by 2 was 4, plus 1 is 5. That means I should be able to go back here, plug in 5, and get 8. Again, you did for that pair, but of course not for this pair. All right. Again, this is going to be a little longer video, guys. I'm trying to go quickly through the note parts. I think I have 6 examples. Again, trying to cover a range of stuff. Like I said in class, I could probably come up with 50 different examples, and you might deal with example 51 on the test in terms of different combinations of things you'll have in the problem, which again you'll see in a minute. All right, so before we can actually calculate our inverse functions, okay? So in order to calculate the inverse functions, we have to remember what our inverse operations are. Again, inverse means opposite. So what's the opposite operations of each other? What cancels out? Of course, we have addition and subtraction, multiplication and division. So we also have exponents and roots. Again, that's the one y'all probably don't think of off the top of your head. We know squares and square roots cancel out, right? If I have x squared, I take the square root of it, cancels out, leaves me x, okay? But it doesn't just apply to squares and square roots. You have cubes and cube roots, fourth powers and fourth roots, so on, so on, so on, okay? All right. So there's 2 ways to find inverse functions. They both basically do the same thing. And again, I'll kind of highlight it once we start doing these problems. First one is called do and undo, okay? So you're basically making 2 columns. In the do column, you're taking your original function, okay? You're going to start with the x in the function, and you're going to tell me what operations we're doing in x in order to actually build the function, okay? And then when we have the undo column, it sounds like we're breaking it down. So when we're undoing it, we're undoing everything we did. So we're doing the opposite order of our steps, and every operation we do, we got to do the inverse operation, the opposite operation. But what we're actually doing is we're not, again, when it says undo, you might think we're taking our original function and pulling it apart. So we're actually building, what the undo is doing is it's building a new function. It's building our inverse function, okay? Switch x and y. Again, this one's a little more algebraic. If you're good with algebra, this is probably easier. This is definitely easier on some of the simpler problems, like the first problem I'm going to show y'all. When you get a little more complicated, honestly, do and undo, even if it's a little more writing, might be better for some of y'all. But again, that's up to y'all to judge. So switch x and y. So you have f of x equals a function, okay? We replace f of x with y. We know f of x and y are interchangeable, okay? So we take out f of x, put y in. So now I've got y equals, some kind of equation, okay? Some kind of function. So I'm going to take my y over here, and the x that's actually in the function, switch x and y, okay? So now I'm going to have x equals something. And y is going to be over here. And then at that point, I got to solve for y. So I got to get y by itself, get rid of everything else that's on that side and get y by itself. That's going to create my inverse function. All right, so let's start off super easy. We've got f of x equals x plus 3. Okay, so we're going to start with do and undo. Okay, so again, we're essentially trying to rebuild this function. So we're always going to start with x. Okay, and again, as you're doing this, guys, if you kind of want to rebuild it yourself over on the side or maybe even underneath it, that's fine. So I'm starting with x. So when you start with x, you then need to look at the rest of this side of the equal sign, all right? The expression. Again, it's not, this just by itself is an expression, okay? It turns into an equation when we set it equal to something, but then it turns into a function when we have that function notation. So just looking at the expression by itself on this side, what mathematical operations am I doing over here to x? All right. So I need to determine what mathematical operations I'm doing and then list them in the order of operations, PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, which is normally pretty straightforward, but it can get a little tricky once you start to get parentheses involved, or you need to treat something like it's in parentheses, even if parentheses aren't listed. We'll get to a couple problems like that later. Okay, later. I don't know why I'm moving my hands like this. Y'all can ignore that. We'll get to that. Again, we got a couple problems where we see stuff like that. But just look at what we got here. Okay, I got x. Only thing I'm doing is adding 3. Okay, so I'm adding 3 to x. And again, if you want to rebuild it up here, stick your plus 3 on it. So I've got everything over here now. So now the only thing I need to stick on it is my function notation. So we're going to say end with f of x. That just means I'm sticking my function notation on it. Again, you could put it on either side. You could put it, x plus 3 equals f of x over here. It doesn't matter. It's the same thing. All right. So now for the undo column. Again, it's might not make as much sense since we only have the one mathematical step here. In the rest of these problems, there's more than one mathematical step. So it should hopefully make more sense why I'm about to do what I'm about to do. But we're actually going to start at the bottom of our list here. Okay. We're still starting with x though. For the first step moves to what looks like the bottom of the list, but it's still starting with x. So again, what I'm doing here now is instead of rebuilding my function like I did here in red, I'm building a new function. I'm building what's going to be my inverse function. And again, let me remind y'all as I'm going real quick, you can slow down at any time, pause this, right? So you can get caught up, go back and listen to something I said. That's the great thing about YouTube videos. But again, I'm trying to keep this under, honestly, guys, I'm shooting for under 40 minutes because I got so many examples. Maybe under 30, even if I can go kind of quick. All right, so as I'm sitting here writing, let me actually go back because I'm talking while I'm writing. So, oops. All right, so after I start with x, again, it's, end with f of x, you're going to start with x over here. So the next, 1, 2, 3, 4 steps, however many there may be, are going to be operations. All right. So going this way, again, what's going to let us go in reverse order. And y'all see that in some of these other examples. So not only are we going in reverse order, when I get to this step, whatever I did here, I want to do the opposite. So instead of add 3, subtract 3. That's what I was starting to write. Okay. So subtract 3. Okay. It's the only mathematical step I did. So now I'm going to end again with my function notation. Okay. So I'm going to put f -1 of x is equal to x minus 3. So these are inverse functions, guys. Okay. And the whole idea with inverse functions actually is y'all haven't seen, I mean, y'all seen it in class, but again, if you're looking at this video, you're potentially looking at this before compositions. If you're looking at it after compositions, then hopefully you understand what I'm saying. The idea with the inverses is I can take this function, plug it into here for x, okay? So again, you don't necessarily need to know this, but again, I'm giving y'all the idea and tying it into compositions. Again, whether you've seen it and remembered it or you go watch that video next. I could take either one of these and plug it in here. Okay, so I'm plugging in x plus 3 for x down here. All right, so I plug in x plus 3, then I've still got this minus 3. Okay, if I did it the other way, and I plugged in x minus 3 up here, it would be x minus 3 and then plus 3 here. Either way, as I'm looking at this, both of these are in parentheses, but I can't do x plus 3. I can't do x minus 3. There's no coefficient out in front of either one of these. There's no exponent. So it basically just turns into combining like terms, all right? I got 3 minus 3. Those cancel out, leave me with x. I got negative 3 plus 3. Those cancel out, leave me with x. So again, it's not something you necessarily need to know, but I thought I'd throw it in there because now that, again, if you've hopefully, if you've seen the compositions of functions in class already, can kind of throw that in and make sense. If I have inverse functions, I should be able to plug each function into the other one, and everything eventually cancels out and leaves me with just x. Because again, think about it. Think about how we did earlier. Okay, if I plugged in x here, if x was 5, if I started with 5, and again, I'll go ahead and do this. So if I plug in 5, 5 plus 3 gets me to 8. And then if I plug in 8 down here, 8 minus 3 gets me back to 5, which was my original x. So with the inverse functions, if I plug either one into the other, it'll work both ways. Everything cancels out and just leaves me with x, which in this case would be 5. So again, this comes from the other slide. If I plug in 5, 5 plus 3 is 8. 8 minus 3 is 5. If I did 12 and 15, y'all see 12 plus 3 is 15. And then if I did it here, 15 minus 3 takes me back to 12. So indeed, those are inverses. Okay. Probably could have left that up for a minute, but I already started racing it. So you might want to go back and pause that just in case you need to kind of absorb it. All right. So now switching x and y. Okay. So when we're switching x and y, it's more, this is explaining the algebra and it's written out. This is just straight actually doing some algebra. Okay. So f of x equals x plus 3. I think the dog's hungry. You can't figure out why. Keep trying to feed him. He's not eating. Keep trying to take him outside. It's not working either. All right. So first thing we got to do, we got to replace the f of x with y. So now I've got y equals x plus 3. Okay. Again, you can rewrite that as y equals x plus 3 if you need to. But again, trying to save a little space. Okay. So I replace f of x with y. And then I'm going to switch x and y. All right. So once I do that, I now have x over here on the left and then y plus 3 on the right. So once you do this and you got x equals, something over here with y in it, now I got to solve for y. I got to get y by itself. Okay. So again, when we're trying to get a variable by itself, our ultimate goal is to get the term with the variable in it by itself. And then, if there's a coefficient or exponent on this, or, again, maybe this is y over 3. It's got a denominator on it. We deal with that after the fact, but I want to get whatever has y in it by itself. Again, in this case, y is just y. So all I got to do is get rid of this 3. And of course, to do that, I subtract 3 from both sides. Here is where we tie both processes in, though. Okay. So once I switch X and Y and start doing my algebra, I subtract 3 here. Look, that's what I did over there. Okay. I'll show that on the next problem, maybe the third problem. I won't necessarily make that connection every time, but it's going to hold true. Okay. So once you start doing your algebra over here, again, that's basically what you're doing in the undo column. So 3, -3 cancel out, leaves me Y. I've now got X minus 3 on the left. And then the last thing you want to do, we replaced f of X with Y earlier. So we want to switch it back to a function notation. But it's no longer f of X. This is now my inverse. So I'm going to do the inverse notation. All right. Hope everybody got that, because again, I'm going to start going a little quicker. Again, you can always rewind the video, listen to something again, pause something. But again, I'm trying not to make a 40-minute video. All right. So now we're going to add on one extra operation. So we had X plus 3 on the last one. Now we got 3X minus 4. Okay. So again, we'll start with do and undo. All right. So again, as we're rebuilding f of X equals 3X minus 4, I'm going to start, I don't know why I made a Y, start with X. That's a bad X. Start with X. Yeah, you can put your X there. So now, ignoring the X, again, I got to look at what operations I'm doing. Okay. I've got this 3 and I've got this 4. So you're saying, what operations do those represent? This 3 represents multiplying. This is 3 times X. And of course, this 4 is subtracting, minus 4. So again, we got to do those operations in order of operations. So of course, multiplying M comes before subtraction S in PEMDAS. So I'm going to multiply by 3. All right. So again, and when you're rebuilding this too as well, or even when you're doing undo and building your inverse function, whatever step you do, you have to do to everything that's there. Okay. So if I had, if I happen to have X minus 2 right here, when I'm multiplying by 3, I don't just stick the 3 here. I would actually be multiplying the entire thing, X minus 2 by 3. Again, that's key for y'all to remember later. Okay. So of course, I don't have to worry about that right now because I only have the X. So I put my 3. Then I got subtract 4. Excuse me. Okay, so I've got subtract 4 minus 4. And again, I built the entire expression now. So I stick on my function notation to turn it from a lonely expression, 3x minus 4, into a function. All right, go to undo. Again, start at the bottom, start with X. So we'll use purple. All right, so again, this is where the undo comes into play, because now I have 2 mathematical steps. All right, so what's going to happen now is, instead of doing multiplying first and then subtracting, what's going to happen is I'm going to do the opposite of subtracting first, and then the opposite of multiplying second. So what's the opposite of subtract 4? Of course, it is to add 4. Okay. So we will stick a plus 4 here. Then what is the opposite of multiply by 3 for my now third step in undo? It is to divide by 3. Okay. So again, I got to divide the whole thing by 3. It's not just, oh, come on. Hey, let's think it's slow. It's not just dividing X by 3. No. Whatever you have there, you got to divide everything by 3. So X plus 4 divided by 3. And then we've done both our math steps. So again, we end with our inverse function notation, f -1 of X. Okay. So what I'm about to show y'all again, I'm only going to show on this problem I'm only going to show on this problem. I'm not going to show it going forward. You can certainly check for yourself. So again, there's kind of two ways you can check it. Easier way is to take a couple numbers and plug them in and see if they work. So let's start with 5. Okay. If I plug in 5 times 3 is 15, minus 4 is 11. So I plugged in 5, got 11. So the opposite should be true down here. If I plug in 11, I should get 5. 11 plus 4 is 15, divided by 3 is 5. Okay. Let's get a little bit of a weird number going on here. Let's get 13. Why not? Okay. So I'm gonna plug in 13. 3 times 13 is 39, minus 4 is 35. So if I plug in 35 here, again, I should get 13 as my answer. 35 plus 4 is 39, divided by 3 is 13. So that works out as well. Okay. The other way you can check it is, again, if you plug one function into another and they cancel out. So this is going to get a little tricky, guys. Okay. So I really need y'all to focus what I'm about to say. So I'm going to plug my inverse function into here. Okay. So I'm going to replace this x with x plus 4 divided by 3. Okay. I've still got my 3 on the outside, and I still have this minus 4 on the back end. Okay. So again, when you're going to simplify this, you're still applying order of operations. Okay. I can't add x plus 4. I mean, I could divide this and have x over 3 plus 4/3 or plus 1 1/3 if you really want to, but I'm just going to leave this like this. So can't do anything else in parentheses. Now I got multiplying and subtracting. So I'm going to start with multiplying. Since I got 3 times x plus 4 over 3, this 3 and the 3 in my denominator cancel out. Okay. So I'm left with x plus 4 minus 4. And again, it kind of looks like we had in the last problem. Nothing else I could do here. So I've just got 4 and 4, which cancel out and leave me with x. So we plugged x plus 4 divided by 3 into here. And our final answer was x, which again is, if you'd like to check it that way, is what we're looking for. Again, I'm going to erase that because I need a little more room. Again, if you want to write that down, again, that's not something I'm necessarily going to test you on, but it's proving to you what we're doing. Okay. The operations cancel each other out to leave us with whatever our original x is. The functions cancel each other out, excuse me. All right. So now switch x and y. I'm going to try to pick up the pace now going forward with the rest of this and the other 4 problems. So f of that, I'll go a little more slowly for this one. Now I'm going to pick up the pace going forward. All right. F of x is equal to 3x minus 4. All right. So again, when I'm doing that switch this way where I switch x and y, I got to get a y first because I don't have one. So we replace that with y. All right. I'm just going to keep it the same color this time. Then I switch it with x. So now I've got x on the left by itself. Again, I'm just switching it with the x. The 3 is still there. So now I've got 3y minus 4. All right. So now I got to get y by itself. Again, same thing I said on the last one. I got to get this term by itself, but now, now it's actually got, something on it other than just being y. But the point still stands. I got to get 3y by itself, and then I can deal with the 3. So to get 3y by itself, I add 4 to both sides. Again, if we look, guys, I'm going to make a little brown star here, brown star there, because if I start drawing arrows, things are going to get crossed. Once I switched x and y, my first mathematical operation was to add 4 to both sides. Again, matches up like it was there, okay? So I've got x plus 4 equals 3y. So now to get y by itself, I got to do divide by 3, because this is multiplying by 3, so I divide by 3, which cancels out. I do it on that side as well. But again, I divided by 3, which is what I did there. So we see that it matches up. Again, this is going to be a little small, so pardon me. X plus 4 over 3 equals y. And again, the last thing I want to do is replace the y back with function notation, but again, it is now our inverse notation. So our inverse function is x plus 4 divided by 3, which is what I had up there, and I just realized I didn't have an equal sign there. All right, so there's the second example. I feel like I've been going for a while already. All right, I had an email. I don't know if y'all heard the sound a couple minutes ago. I was just checking Dr. Buss sent us an email. All right. So 4 more examples. Again, I'm really going to try to motor through these, but this video is going to wind up being a little lengthy, but I need y'all to bear with me. All right. So do and undo. F of x equals 2x to the 4th minus 5. All right, step 1, do. Start with x. Again, let's build it as we go. I'll build this one as we go. This is probably going to be, oh no, because I kind of need to show my other ones. I'll keep doing this. All right, so now looking at this, okay? 2x to the 4th power minus 5. So again, there's no parentheses here. There's the really only place you could say where there might be parentheses is around the x, but you'd still be doing the exponent to it. You'd still be doing the 2. All right. There's no, because all this is saying is we're taking x to the 4th power right now. All right. If they wanted there to be parentheses here where it was 2x, quantity of 2 times x to the 4th power, there would be parentheses there, but there's not. Okay. So again, I got x. What are the 3 operations I'm doing? I'm multiplying by 2. Got an exponent of 4. Which again, exponents are an operation. They're the E in PEMDAS, and subtracting by 5. So exponents are first in my order of operations. So I got to list my exponent. And the way I'm going to write it here is I'm going to take the 4th power. Again, we also call exponents powers. Y'all are going to see the language is going to line up when I do the undo. Okay. So why I'm saying power, I mean, I guess you could say take the 4th exponent. That sounds a little weirder. If you need to write exponent though, so you understand, go ahead. So I take the 4th power. Okay. Stick my 4 up there. I'm going to multiply by 2. All right. And then I'm going to subtract 5. So got my minus 5. And then I'm going to end with f of x. All right. F of x equals 2x to the 4th minus 5, just like I have over here. All right, so now the undo. Again, not really undoing anything. We're just doing things in reverse order to build a new function. But anyway. All right, 1. Start with x. Again, even here, end and start, those are opposites if y'all hadn't noticed that. So start with x. Okay, I'll go back to blue. All right, so now I got 3 steps. So again, I'm going to do these in reverse order, the reverse operations. So here, instead of subtract 5, I got to add 5. All right. Here, instead of multiply by 2, I got to divide by 2. Divide by dose. All right. And then step 4, take the 4th power. So again, power is exponent. We said the opposite of exponent is root. So we got to take the 4th root. Again, y'all are probably less familiar to seeing these. So what that means is we got to take this whole thing, stick it under again, I'm going to call it a radical sign, not a square root sign, because that's the technical name, the radical sign. And if I didn't stick the little number in here, which is called the index, again, we assume it's a square root, but it's actually the 4th root. So I'm going to put a 4 right there for, again, it's called the index. Okay. So I take the 4th root, and then I'm going to end with my inverse notation. Since I'm running out of room, I'm actually going to stick over here, but either way, it's fine. All right. So my inverse function of 2x to the fourth minus 5 is x plus 5 divided by 2 to the fourth root. So the fourth root of x plus 5 divided by 2. All right. Switch x and y. So what I'm going to do now here is I'm just going to go ahead and write y equals 2x to the fourth minus 5. So just go ahead and replace f of x with y. Switch y and x again. So x equals 2y to the fourth minus 5. All right. So again, I have got to get y by itself. So I got to get 2y to the fourth by itself, then deal with the 2 and the 4. So I'm going to add 5 to both sides. Again, that's the first step I did down here. So x plus 5 equals 2y to the fourth. Okay. Again, so you say, well, what do I do next, Coach Sharp? Do I divide by 2 or take the fourth root? So if you take the fourth root at this point, you're taking the fourth root of everything. Okay. The fourth root and the fourth power here would cancel and still leave me with y. You don't write this down, by the way. I'm showing you that why this isn't correct. But you still have the fourth root of 2 times y. The y is outside of the square root over here. So that's incorrect. Okay. When you have a exponent, that's usually the last thing that we get rid of. Come on. Computer's being slow, guys. I'm sorry. And I'm realizing again, I'm taking way more time with each example than I'm intending. This video is probably going to go way longer than I was thinking. I do apologize for that, but again, at the same time, I'm trying to give y'all as many examples as I can. So, all right, divide by 2, which again was what the next step that we did. So x plus 5 divided by 2 equals y to the fourth power. And then lastly, I take the fourth root for the fourth power and fourth root cancel out. I do it over here as well. Yeah, I'm going to rewrite it over here just so I have room. Take the fourth root was the last thing I did. So the fourth root of x plus 5 divided by 2 is equal to y. And again, lastly, I'll do it in black. I will replace that with my inverse function. It's supposed to be a -1, I promise. My inverse function notation. All right, there we go. Oh, I'm missing. All right. Third example. All right, 3 more. I'm going to try to go through them quick. Okay. X squared minus 6 over 3. Okay. So I mentioned this earlier in the video, if it seems like it was an hour ago. So this is one of those things where you need to act like there's parentheses on something even if it's not listed. Okay. If your original function, you have a fraction like this. Okay. So you have a whole numerator over this. It's, if you had x squared over 3 and then minus 6 was separate, again, we would actually treat that. We would treat it a little differently, although in that case, even if just the x squared was over the 3, we're still going to do what I'm about to say here. So anytime you see a function or a fraction in your original function, you need to pretend like the numerator is in parentheses. Okay? So we need to pretend like this is parentheses because that's going to affect our order that we do and undo in, and of course our order that we are going to switch x and y in when we get to that. All right. So for do, all right, I'm going to start with x. This is probably what's taking so long. I got to rewrite this every time. So start with x. Okay. Again, I'll kind of rebuild it. So there's x. So again, we're treating like this is like it's in parentheses. Let's think about order of operations. Parentheses are first. Okay. So again, I said in class, if y'all never really thought about this, of course, parentheses aren't actually an operation. You don't calculate anything just because you put a set of parentheses around. Okay. What the parentheses do, though, is separate, part of the problem from the rest of the problem. And it tells you what's ever inside parentheses. You need to apply order of operations to just what's inside the parentheses, and then look outside the parentheses and apply order of operations to whatever is outside of the parentheses. So if I'm inside the parentheses, I have an exponent and I'm subtracting 6. Okay. So I'm going to take the second power. I'm going to write it like this again to keep our language the same. You can say square x if you want to. That's fine. So you can say square x, and then on the undo, we get that square root. You wouldn't be square rooting x at that point, though, because you'd have a bigger problem. So I'm just going to leave this, take the second power. Okay. So throw the second power up there. I'm going to subtract 6. Step 4. So now I did everything inside. So now look outside. So it would be the divide by 3. Okay. So divide by 3. Again, this is why it's important, because now everything I already have, I'm dividing by 3. Again, I'm not just sticking it under x squared. And then I end with my function notation. So I say, in the interest of time, I'm not even going to write it, but it's really only saving a couple seconds. All right. So undo. All right. Start with x. Will the light blue show up? Yeah, I think it's good enough. I hope it is, because I can't go back and edit it once it's in the video. So let's do dark blue. Questioning myself. All right, divide by 3. What's the opposite of that? Multiply by 3. Okay, so stick a 3 out in front. Subtract 6. The opposite of that is to add 6. And then step 4, again, instead of taking the second power, you're now taking the second root, which again is just, I'm phrasing it like this, but again, the second root is just a square root. So you can just leave that. Again, if there's no index here, we assume this is a square root. If you want to put the 2 there, I'm not going to penalize you. But again, what you need to realize on test is you're probably not going to have a 2 there, in your answer on like a multiple choice test. Okay. So there's that. And then we end with our inverse function notation. So again, I'll just kind of throw it over there. I know it's smaller. All right. So again, I'm going to go ahead and throw this over here, doing the switch x and y. Go ahead and replace this. So y equals x squared minus 6 over 3. Go ahead and flip x and y. So x equals y squared minus 6 over 3. So again, this is what you got to realize. Like, the 3 just isn't under y squared. Okay. If it was just under 6, we could even divide that. So again, you always want to treat it like it's in parentheses like I did here. And then you say, okay, so I got to get rid of the 3 before I can deal with, with the numerator. And then once I get to the numerator, I'm going to have to get rid of the 6 before I deal with the y squared. All right. So I multiply by 3, which is going to cancel out here. 3 times x, again, multiply by 3. That's our first step. Okay. 3x equals y squared minus 6. So again, I want to get the term that has y in it by itself. So I want to get y squared by itself. So I'm going to add 6. Okay. So again, that cancels out. 3x plus 6 equals y squared. What color can I use? Is orange going to show up on that? Yeah, good enough. All right. Take the square root of both sides. That cancels out. Again, I'm going to move it over here. So it leaves me with y equals the square root of 3x plus 6. Same thing I got up there. And again, always remember when you're doing switch x and y to swap that back out from the inverse function notation. All right. I'm try to do these last two problems in 5 minutes because it's 8:55 real time. I really don't know if I can do that, but I'm going to try. And again, just as a reminder, guys, you could either do or undo or switch x and y, even if I didn't label it right there. They both do the same thing. Again, just to remind you that. Again, I feel like I try not to be confusing, but I want to give y'all multiple ways to do things. But again, ultimately, at the end of the day, guys, pick whichever one works best for you. All right. So we'll do and undo. Change out the color now. Let's go white. All right. So, of course, 1, I'm just going to put an X at this point. Start with X. Okay. Put my X up there. Again, just in the interest of saving time. So 2. So now I got to see what I got. Okay. So now I got some parentheses. I actually have some parentheses built into this problem. So I got to see whatever's in parentheses. I got to deal with that first. Then I can deal with what's outside the parentheses. So what's inside the parentheses is just the x minus 4. The 3 is outside the parentheses. I will deal with that shortly. But all that's inside the parentheses is the x minus 4. So step 2 is to subtract 4. Okay. Again, rebuilding it over here. So now I can look at what's outside. Multiplying by 2, taking an exponent of 3. Exponent is first in order of operations. So I'm going to take the third power. All right, so I got to put parentheses around this because this whole thing, I'm taking the third power. Then I can multiply by 2. Multiply by 2. And lastly, end with my function notation. All right, undo. Yeah, I'm not going to get done by that. All right, so start with X. What's the fun color? Is green going to show up on here? Purple should, right? Come on. All right, we'll go purple. All right, so opposite of multiply by 2. Divide by 2. All right, so divide that by 2. Opposite of take the third power is I'm going to take the third root. So I got to put this whole fraction under the cube root. Okay. Step 4, the opposite of subtract 4 is to add 4. So this add 4 is actually over here separate. It is not under this cube root. Okay. And then end with my function notation. There we go. All right. So again, let me actually write the title this time just to avoid confusing y'all. So switch X and Y is what I'm doing over here. So again, I'm gonna go ahead and replace f of x with y. Y equals 2 times x minus 4 cubed. Switch x and y. X equals 2 times y minus 4 cubed. Again, guys, I'm recording this at night. They're watching TV, and I'm kind of out in the hallway, so I apologize for the background noise. All right. So again, this is where you got to look at and say, okay, what do I got to get rid of first? If you're thinking exponent and you say, okay, I got to cube root this side. Again, if you cube root that side first, you got to cube root the whole thing. So your cube root would get rid of the 3 and leave you the y minus 4. Again, don't write this because this is incorrect. But you still have that cube root of 2 times y minus 4, which again is what we do not want. Okay. So again, that's what you got to realize, guys, is when you're doing when you're performing operations on something, you have to do it to everything that's there. You can't just, you can't just pick and choose. Okay. Like I can't just add 4 to this right here and then get, I don't know why I put it 2. X plus 4 equals 2 y cubed. Like you can't do that. Okay. It's not how it works. Yeah, it's 9 o'clock and I haven't even gotten through this problem yet. I'm sorry, guys. I know this is a long video, but I really appreciate y'all bearing with me. I know it's kind of late in the video to say this, but maybe break up some of these examples if you need to. All right. Divide everything by 2. That cancels out. Divide this by 2. Again, that was the first step we did. So x divided by 2 is equal to y minus 4 cubed. I take the cube root. I kind of already crossed itself out on accident. So take the cube root, okay? So the cube root of x over 2 equals y minus 4. Is this pink gonna show up? Yeah, good enough. All right, so add 4, that cancels out. Kind of add 4 down here. So again, y equals the cube root of x over 2 plus 4. And of course, replace this with my inverse function notation. So this would be my inverse function. All right, last problem. All right, f of x equals the square root of 2x plus 3 minus 5. So again, this is a situation where even though there are not parentheses built into the problem, we got to pretend like 2x plus 3 is in parentheses, okay? Again, this is why we do that, okay? If we don't, and it might take you a minute to realize when you need to do it, when you don't. I'm trying to show you the situations when you do. When you have something in a numerator, like I showed a couple problems ago, and when you have something underneath even if this was a cube root or 4th root, when you have something under a radical sign, okay? Because this is what happens if you don't. And again, I'm not going to write do and undo yet. Okay, I start with x. Okay, so what operations do you see? You see, okay, I got 2, multiply by 2, add 3, subtract 5. Again, that should also throw up a red flag though. So you should say, since the plus 3 is under the square root sign, the negative 5 is not, I can't go ahead and combine this. So that again should be another hint that, this is separated. Okay. But then I got the square root. Okay. Again, square root actually falls into exponents because if y'all remember back to 9th grade, if y'all learned this, an exponent of 1/2 is the same as a square root. Okay. So, a root is the same thing as an exponent in terms of order operations. It's like how multiplication and division go together, adding and subtracting go together, which you talked about. So you say, okay, I got a square root, which I treat like an exponent, multiplying, adding, and subtracting. So I got to do the square root first, okay? So I do the square root first, multiply by 2, add 3, subtract 5. So if you're doing little order of operations without putting this in parentheses, this is what you would get. You would then do 3 minus 5 is -2. So 2 times the square root of x minus 2. Clearly not the same thing I got. Okay. Oh, no, I hit the wrong thing. No. Come back. All right. So, all right, we're going to do and undo. Again, we're going to start with x. Number 2, again, treating this like it's in parentheses. So I've got multiplying and adding. So I'm going to multiply by 2. Okay. I'm going to add 3. All right, so I did what's in the parentheses, the invisible parentheses. So now outside of that, I have a square root, which is like an exponent, and -5. So in terms of order operations, I'm going to take the square root, and then, or again, in this case, I'm going to put the second root again, if you put the square root, that's fine as long as you know how to reverse it. Taking a square. So I take the second root, which again, just the square root. If you want to put the little 2 out there, I'm not going to get mad at you. 5. Step 5 is to subtract 5. And then our last step is to do the function notation. Well, I was about to write function notation and with the function notation. I'm sorry. And with the function notation. All right. Again, I have gone way too long on this video. I'm just trying to be comprehensive with these examples. Kind of regretting it already, but I don't want to stop now. All right, undo. All right, start with X. Let's change the different colors. Is the screen going to show up? No, definitely not. How about yellow? Yellow shows up. All right, start with X. Opposite, subtract 5, add 5, plus 5. All right. Opposite of take the square root is to, or take the second root rather, is to take the second power. So everything I already got, I got a square. Okay. Step 4. Opposite of add 3 is to subtract 3. Okay. And then finally, the opposite of multiply by 2 is to divide by 2. And again, I got to divide the whole thing by 2. And I end with function notation. Can somebody, I think one of your classmates has blown me up on. Remind, 9 o'clock at night. So f -1 of x. All right. That took up a lot of space. So let me move over one more slide to do this with switching x and y. Okay. So this is, I'm just gonna leave the white background for this one because I'm trying to finish. All right, so come on, respond, hurry up. All right, so f of x square root of 2x plus 3 minus 5. Okay, so switching x and y. All right, so again, I'm going to just start by going ahead and replacing y here. Y equals square root of 2x plus 3 minus 5. Flip x and y. X equals square root of 2y plus 3 minus 5. Okay. So people blow me up at 9 o'clock at night, man. Just got an email. All right. So again, we got to say, what do we got to get rid of? Okay, so again, you almost want to treat this like it's the term with the y. So we want to get rid of everything outside of the square root. Okay. So this is our add 5. Again, if you go back and look, this was our first step. Okay. So x plus 5 equals square root of 2y plus 3. All right. So now to get to the y, I got to get rid of the radical sign. I got to get rid of the square root sign. So I got to cancel that out by squaring it. Okay. So I square x plus 5. So x plus 5 squared equals 2y plus 3. At this point, hopefully y'all know the algebra from here on out. Minus 3. So x plus 5 squared minus 3 equals 2y. And lastly, again, running out of room, we're going to have to move it. Divide everything by 2. So y equals x plus 5 quantity squared minus 3 divided by 2. And I replace y with the inverse function notation. How I'm taking, again, just trying to go through it, even going through it kind of quick. It almost seemed like that took about 10 minutes per example, showing it both ways. Again, I know this video is very, very long. I do apologize once again, guys. But just trying to, again, since we only did it one day in class, just trying to show you all as many examples as I can, just for whatever you might see on the assignment that I give you or on a test. I hope that was comprehensive. Again, I apologize for the length. You know, if you need to break this video, again, obviously you're at the end of it now. So if you watched it all the way through, I guess this is a moot point, but you know, hopefully, you know, y'all took some short breaks in between instead of just having to watch this whole video for however long it wound up being. And I hope y'all learned something because again, I hope I was comprehensive enough where you didn't just have to watch that whole video and still not pick up anything and still have to, you're still stuck or you have to, come to me for office hours or something like that. Again, of course, that's not my intention. I make these videos hopefully to help y'all understand because, again, I want to provide that extra resource for y'all. And of course, I also don't want it to be, an hour of your life or whatever this wound up being wasted. So video's over. Again, of course, always, if you have any questions, let me know. Until next time, this is Coach Scharf, and I'll see y'all later.